Welcome to this case study lecture on large intelligent surface antennas for making the reflective radio smart. So let's see the overview of this case study. So large intelligent surface antennas are the two-dimensional artificial structures like metamaterials with a large number of reflective surface antenna elements. It is a promising reflective radio technology which is useful for programmable wireless environments in a smart way. That is, it is used in software-defined radios. We can control the parameters through a software. So Lisa adjusts the reflection of the incident electromagnetic waves. Thus, wireless environments can be software defined according to the various design objective. So in this block diagram, we can see the various technology evolving through reflective radio techniques. So in this large intelligent surface antennas, reflective arrays and reflective devices both are combined. So our problem statement of the case study is when we are using the more and more base station antennas and wireless terminals to support the exponentially growing mobile traffic and massive wireless connections, the power and spectrum consumption as well as the implementation cost increases. So recently, the reflective radio technology is emerged as the solution for next generation communication system to make the spectral and energy efficient systems and reflective devices which uses very less power active components, and also it transmit the signal to receivers with um, electromagnetic scattering principles. So what is a reflective relay? So it is used to enhance the quality of service of users in primary system which suffers from unfavorable propagation conditions. So reflective relay is used for a large intelligent surface antennas. It is also known as intelligent reflective surface. It is a large number of reflective radio elements which adjust the reflection of the incident electromagnetic waves. So it enables the reflected signals to add at the coherently add at the receiver without introducing the noise. So it improves the signal to noise ratio. And next, what is the reflective radio? So in this diagram, a general model is given where it consists of a transmitter and receiver and also a reflective device. So reflective device sends its own messages to receiver through backscatter modulation, or it assists the information transmission from transmitter to receiver. So reflective device modulate the information or change the phase of the incident signal into the desired one by varying its load impedance. So the challenge of this uh, antenna implementation is given. So in order to improve the transmission efficiency, the higher order modulation like quadrature amplitude modulation can be applied. So in this, number of discrete load impedance states attributes to the modulation scheme. So we have a more number of reflectant states means the higher the modulation order is required. The key issue is backscatter modulation is to design the appropriate reflection set corresponding to the signal constellation. So backscatter link is very weak, especially when the carrier frequency increases. So to overcome such drawbacks, a solution is to deploy a large number of reflective radio elements at the reflective device to enhance the reflective radio performance. So which leads to the idea of large intelligent surface antennas. So the reflective arrays and reflective elements are combined. The solution is it is a two-dimensional artificial structure comprising of large number of passive radio meta elements, that is metamaterial antennas with unique properties of incident electromagnetic waves such as negative reflection or refraction, perfect absorption and anomalous reflection. So some works exploit the laser to steer the incident RF signal to desired directions, resembling a tunable reflective array. So it is similar to beam forming. So adjusting the length of the waveguides corresponds to the changing the phase of the re-radiated signal and forming the desired beams. So the demonstrated systems of the large intelligent surface uses the hardware available only in recent years with tremendous advancements in metamaterials and fabrication technologies. So compared with the traditional reflectors that is parabolic reflectors which have limited tuning capabilities, the features of the modern laser are that the beams can be redirected at any arbitrary angles due to the use of metamaterials which have a negative reflection index, and also it can be electronically tuned in real time. So the implementation of LISA can be integrated into various environments such as walls, ceilings and buildings. So LISA is recently considered as the key enabler for controlling the behavior of wireless environments in next generation wireless systems. So implementation of large intelligent surface antennas. So it consists of a LISA and then DAC board for controlling the amplitude of phase and of LISA, and then copper backplane to avoid the signal leakage to the surrounding environment, and also microcontroller, it is connected to the access point. And benefits of this antennas are the reflection mechanism of LISA brings several advantages such as low power, ultra low power consumption, no self interference and no additional thermal noise added to the signal. So and also it used as a large number of reflective radio metamaterial antennas. LISA can do much more than just being the reflective relay. So it is for interference cancellation and also assists the spectrum sharing in cognitive radio networks and increases the secrecy capacity in terms of physical layer security. And it can also collect and focus the electromagnetic power in environment by exploiting its large aperture and acts as an auxiliary wireless power source for energy harvesting devices. So next, design of large intelligent reflective surfaces. So it consists of an copper and then pin diode and then biasing line and F4B substrate. So in the substrate is F4B and pin diode is used. It is for high frequency applications and an equivalent circuit is given. So outcome of this antennas. So main idea of LISA is to make the scatterers in the aperture electronically tunable, which can be achieved through introducing discrete elements such as varactor diode or pin diodes or ferroelectric devices or MEMS switches within the scatterer. So it results in the whole surface can be electronically shaped to adaptively synthesize the large range of beam patterns. So it can produce any beam patterns. So at high frequencies, tunable electromagnetic materials can be used like ferroelectric films, liquid crystals, and also graphene can be used as the reflective element with a lower cost. So this is enabled the LISA to become powerful beamforming tool in recent years. So it also combines the best features of both reflective antennas and also an antenna array. Thanks for listening.